While we are able to successfully get the result, there is one problem. Let's go to our code here and then call this particular function once again, and you will see that there will be an error. So I'm copying and pasting, and let's run the code here now. When I run this, you'll see first time we get an output. There are 77 products. The second time we are getting an error saying that there is a null pointer exception in the create connection function of our JDBC product DAO. So if I go over there, you will see that it is trying to load the driver class name. While we never injected the driver class name, we injected a connection. The reason for this is, so first time when we call this particular function DAO.count, it goes to the JDBC product DAO count function and calls the create connection, where the connection is an object that we got dependency injected. And since we are using that inside the try with resources block, as soon as you come out of this try catch block, the connection gets closed. So the next time when you are calling this function DAO.count again the control comes here, and when the connection is being obtained using create connection, you will see that the if condition fails because connection is not null, but connection has been closed. So because of this, now the if condition is failed and it's trying to load the driver class name where we didn't supply the driver class name. So if you look at the app config 2, we don't have the driver class name injected to our JDBC product DAO at all. So the JDBC product DAO is automatically wired with a connection object because of the auto-wired annotation, and hence we are getting the null pointer exception over here. So if you want to pictorially represent the same, first time when we called the DAO.count, the count function was called over here, and that count used the connection which is open and there was no problem. But as soon as we hit the database and got the product count, the connection got closed. So the connection object still exists, but it is closed. And next time when I call the count function again, it is trying to use a connection which is now stale because the connection has been closed. So there are a couple of solutions that you can come across with. Every time you want a connection, you manufacture a new connection like this. So make it as a prototype. But unfortunately, auto wiring is done only once and you would only get a single prototype object. So this will not help. So if I go to app config 2 over here, and then annotate this as a prototype bean by typing @scope of prototype and importing the same. This is a prototype bean, but this is a singleton. When we got the DAO object, we got a singleton over here. So DAO2 also corresponds to the same thing. When I say DAO.count, it uses a new connection object, but the same connection object is also there in DAO2. For example, if I make this as DAO2 now, both DAO and DAO2 reference variables refer to the same DAO object because DAO is a singleton. When that singleton object was constructed, a new connection was injected. It's the same connection, still you will have the same problem. The other solution would be, for example, if I go to app config 2 and then annotate even the DAO bean also as a prototype. This may solve the problem temporarily. Let's go and run the same. You'll see that now I do not have that problem. I got it. But if I make use of the same DAO object and call this another time, I might run into problem. And that's because now here we are using the same DAO object, the connection is not recreated. So even making the objects as prototypes also is not a solution. There is also another issue when you are using the common connection object. If there are multiple clients trying to make use of the same connection, then all of them will be working under the same transactions, which means that if one of the client commits the transaction, it affects the other clients also. So the solution is to use a connection pool where an application creates a bunch of connection objects that can be reused. Instead of destroying those connection objects, a connection object is used by the client and then connection is closed, but the connection gets recycled and will be available in the pool once again. So there are a lot of advantages of using the connection pool. Number one, every client gets its own connection object, which means that there will be a separate transaction. There won't be any transaction conflicts. Number two, creating a connection object is a background process. That means it won't affect the application's performance. Number three, each time a connection is closed, the connection gets recycled and no new object has to be constructed or no connection object gets destroyed and garbage collected. So this improves the performance. Plus, a client doesn't have to spend any time in opening a new connection, because on an average it takes almost a second to open a new connection. As well as if you close the connection and destroy that connection object, there will be an impact on garbage collection also. In Java, a connection pool is represented using an interface called data source from Java x.sql package, which has a function called as get connection. So all we need to do is find an implementation for a connection pool and make use of that. While there are many connection pool implementations, the most popular one is one from Apache, which is called basic data source. So first, let's add the relevant libraries to our pom.xml. So let's go to mbnrepository.com, look for dbcp, which stands for database connection pool. And the most common one is the Apache Commons DBCP, and the artifact ID is Commons DBCP2. Click on the same. And let's take the latest version 2.7.0. Here we have a XML. We copy the dependency, come back to our pom.xml and scroll down somewhere here, paste after the lombok, format it and save it. As soon as I save, the jars will be downloaded from the net. So now if I go to Maven dependencies, you will see that there's a Commons DBCP2, its dependency, the Commons pool 2 and the logging jar. Now that it is done, let's do one thing. Let's create a new app config by copying app config 2 and pasting it as app config 3. Let's open the same. While we need the DB information, we don't need the connection anymore, but instead we will create a new bean here which returns something called data source, which is from Java x.sql package. Let's call it as data source and create a variable of type basic data source from Apache package. Let's call it as BDS equals to new basic data source, and we need to return this particular object. But in between, we have to initialize this object also. Let's not forget to mark this as @bean. There are two sets of properties you want to initialize for the basic data source. The number one is the DB connectivity information, which is a bunch of these values. The second one is about the pool configuration. So first, let us set the DB connectivity information. So if I type here bds.set, you'll see that you get a lot of setters, and one of them is set driver class name is the variable that we have here. bds.set URL, we have the URL, bds.set user name, and the variable we have is called user. Then we have bds.set password, and we have the variable called password. We also want to specify how many connections you want in advance. For example, I can say when the connection pool is constructed, what is the number of connections to be present initially? So I can say here bds.set initial size. Let's say I want initially 10 connections to be ready. As in when a client is asking for a connection is given from the pool, and so the number of active connections starts reducing. And once it becomes 0, then new connections are added automatically. This means that there will be more number of connections in the connection pool, but you can also set a cap to this by typing bds.set max total and then supply. Let's say, for example, I want a maximum of 100 connections, not more than that. That means if there are at a time 100 clients that are consuming the connections, the 101st client will have to wait. You can also specify how long that has to wait. You have something called max wait in milliseconds. Let's say the max wait period is 500 milliseconds. That means half a second a client will have to wait before getting an exception. But within that half a second, if there is a connection being released, that connection can be reused by the new client. Now, once all the clients that are consuming the connection starts closing the connection, they all come back to the connection pool as idle, because initially there was 10, but now maximum of 100 have been reached. Now the connections being closed will become idle, and you can always say how many idle connections you want to keep. So I can say bds.set max idle, and then I can say 50, for example. Now likewise, you also have few other options such as bds.set min idle. For example, I can say at any given point in time, I always want two connections to be idle so that in a background process, connection pool creates new connection objects. Depending on which implementation of a connection pool you are using, these properties may change. So for the most common basic data source, these are the most popular settings that you may want to do. Now that we have a connection pool ready, we do have here an object of a JDBC product DAO, but the JDBC product DAO has no dependency on this particular bean. Let's get rid of this scope also. We don't want this to be a prototype. Both of these are singleton beans, but every time a JDBC product DAO function is called, such as count function is called, I want the count function to use a new connection from this particular pool. To do that, let's go to the JDBC product DAO. We probably may not use this particular variable at all, but just to make sure that our previous programs work, let us keep this. We also will say this time a private data source, and let's call it as data source itself as the variable. We have to import it. I'm going to press Command Shift O to import the same from javax.sql package. And we want this to be automatically wired. So I'm going to copy this and paste over here. While the data source gets injected because of my app config 3 here. So there is a bean, there is a bean. And when Spring collects this particular bean object, it realizes that there is an auto-wire dependency. This qualifies for the dependency and this object gets injected automatically over here. The auto-wiring also first is done based on the name. For example, Spring will look in the container whether do we have a bean whose name is data source, and look at this, we have the exact same name here. But in case if the function name here is different, then it's going to check is there an object of this data type, and the object data type here is a data source. Even if you had written basic data source implements data source, it qualifies as an instance of data source that gets injected. So it's always a good practice to maintain the same name for both the bean as well as the variable here. We may run into one problem with this one. We will come back to that in a minute. But we'll first modify our create connection function such that if there is a data source and it is not equal to null, so I'll say here if data source not equals to null, then we will simply return data source dot get connection. So that is a function that we would be using to retrieve an idle connection, and that connection object is going to be returned, and that is going to be used over here. At the end of this try catch, the connection gets closed, which means the connection is returned back to the pool. Pool will automatically clear its resources and then reset, and it's ready for new client as well. Let's go save all our files. One last thing we have to do is to make sure that our program uses app config 3 now. So I'm going to import the same. When we run this code, we may come across an unusual error. Let's give it a try. When I run this code here, you'll see that we have an exception. Let's figure out what is the problem. And the problem is in the line here. It says error creating bean with name JDBC DAO defined in app config 3. Unsatisfied dependency expressed through the method JDBC DAO, parameter 0, nested exception is it's going to say here no qualifying bean of type connection available, and it says expected at least one bean. Now the meaning of this is when Spring is trying to resolve the dependencies of this, it finds that it has dependency on two of these particular variables, whereas it finds a matching bean only for this particular auto wiring, not for this. And hence it is giving an exception saying auto wire dependency injection is failing. I can just get rid of this @auto wired and the problem would be solved. But in case if I go back to the program and then change here to app config 2, then it will fail because then auto wired is not present for this. So in practice, we don't come across with this problem because if at all we have declared a variable and it needs to be wired, we need to have connection. So somewhere we would be having a connection object also. However, in this case, I want to maintain this for my compatibility with other programs, but I really don't need a connection in case if connection is not available. So what I can do is I can go ahead and I can give an element here called required equals to false. indicating that, hey, if you find a connection, inject. If you don't find a connection, don't throw me an error. Now the same thing I also would like to give it to this one, because if I'm running the previous program with appconfig2, this is what is used and there is no connection pool with appconfig2, and this would cause the problem. So I'm going to copy this required equals to false, and then I'm going to paste over here. Now in practice, we generally don't use this, but this is a peculiar situation because we are learning with different configurations and I don't want to really delete this code. So let's go back here now and then run the code, and I should be getting an output without a problem. But I think I still see an error, probably because when I copy pasted the appconfig2 to appconfig3, I forgot to delete this one where it was trying to inject the dependency. Now I don't have any dependency over here. So obviously this is an independent bean. This is another independent bean. But Spring collects this bean object and finds that it has a dependency on a data source, and it automatically injects that or automatically wires the same. So let's save all the code and then run our program and see that we get an output without a problem. Of course, if I uncomment this, I should still be able to get the result, because this time I have a dependency here, but it's really not required and Spring will not cause any problem at all. So one last time I'm going to run the code and see that I get the result without any problem.